Breaking news. A massive star in the Andromeda Galaxy has exploded, lighting up the cosmos with a brilliant supernova. The explosion is so bright it outshines billions of stars, even though it happened 2.5 million years ago. This blast hurls heavy elements into space, the building blocks of planets and life. The shockwave will ripple through Andromeda, triggering the birth of new stars. The universe just handed us a gift. Let's see what we learn. This isn't the first time a star exploded in Andromeda. In 1885, astronomers spotted a new point of light, S Andromeda, near the galaxy's center. Back then, Andromeda was thought to be a nebula inside our own galaxy, so the brightness of this nova was baffling. The technology of the time couldn't measure the true distance, leaving astronomers puzzled. S Andromeda was actually the first supernova ever recorded outside the Milky Way, but no one realized it. The event hinted at a much larger universe than anyone imagined. Decades later, we learned it was a Type Ia supernova, a white dwarf exploding after stealing material from a companion star. These explosions are so consistent in brightness that they became standard candles for measuring cosmic distances. If astronomers had known this in 1885, they could have measured Andromeda's distance right then. Instead, the mystery pushed science forward, inspiring better tools and bigger questions. S Andromeda was a clue that changed our view of the cosmos. Sometimes, a single star can rewrite the universe. For centuries, Andromeda was just a fuzzy patch of light. The little cloud. Most thought it was a nebula within the Milky Way until the 1920s, when astronomers debated its true nature. Harlow Shapley argued it was a local gas cloud. Heber Curtis believed it was a distant island universe. The answer came with Edwin Hubble, who used the Mount Wilson Observatory's powerful telescope to find Cepheid variable stars in Andromeda. These stars pulse at a regular rate, revealing their true brightness and distance. Hubble's calculations showed Andromeda was nearly 1 million light-years away, far outside the Milky Way. Suddenly, the universe became vastly larger. Andromeda wasn't a nebula, it was a galaxy filled with billions of stars. Our Milky Way was just one of countless galaxies in a cosmic ocean. This discovery changed everything. The universe expanded overnight, and our place in it shrank. The fuzzy cloud became a world of its own. The great debate was settled. We are not alone in the universe. Andromeda is our galactic neighbor, an island universe next door. So, what is Andromeda really like? It's a spiral galaxy, like the Milky Way, but much bigger. Andromeda's disk stretches over 220,000 light-years, twice the size of our galaxy. If you could see its full span, it would appear 6 times wider than the moon in our sky. It's the most distant object visible to the naked eye, containing about 1 trillion stars. That's more than double the Milky Way's star count. Its total mass, including dark matter, is over 1.5 trillion times the mass of our Sun. At its core is a bright bulge of old stars, surrounded by majestic spiral arms where new stars are born. The entire disk rotates in a cosmic dance, with stars closer to the center orbiting faster. Andromeda is wrapped in a massive, invisible halo of dark matter, which holds the galaxy together. This dark matter halo is key to understanding how galaxies form and evolve. Andromeda isn't just a collection of stars. It's a dynamic, complex system. Its gravity is slowly pulling the Milky Way closer, setting the stage for a future collision. In our local group, Andromeda is the heavyweight champion. Zoom into Andromeda's core, and you'll find a surprise: 2 bright points instead of 1. The Hubble Space Telescope revealed this double nucleus, sparking debate. One theory says it's a single lopsided ring of old stars orbiting a supermassive black hole, an optical illusion from our viewpoint. Another theory suggests the second nucleus is the remnant of a smaller galaxy Andromeda devoured. Either way, at the heart of it all lurks a supermassive black hole, about 140 million times the mass of our Sun. This black hole anchors the galaxy's center, shaping its fate. The double nucleus is a clue to Andromeda's violent, complex history. Even the heart of a galaxy can hold secrets. Andromeda is a cosmic zoo, home to exotic objects like low-mass X-ray binaries, neutron stars, or black holes stealing gas from companion stars, shining in X-rays. These systems, especially common in Andromeda's bulge, reveal the extremes of gravity and matter. The galaxy also hosts AE Andromeda, a luminous blue variable, one of the brightest, most unstable stars known. These massive stars live fast, erupt unpredictably, and die young in spectacular supernovae. Studying them helps us understand the limits of stellar evolution. X-ray binaries show us the endpoints of stars. Luminous blue variables show us the most extreme lives. Together, they reveal the rules that govern all stars, including our Sun. Andromeda is close enough to study in detail, but vast enough to see the big picture. It's a perfect laboratory for exploring the universe's wildest phenomena. These cosmic monsters shape the galaxy's story. Andromeda's diversity is a window into the life cycles of stars. Where do Andromeda's trillion stars come from? Stellar nurseries, vast clouds of gas and dust in the spiral arms. The brightest is NGC 206, a giant cluster of hundreds of hot, young blue stars. These cosmic babies are just 10 million years old, lighting up their surroundings and triggering new waves of star formation. Gravity pulls gas clouds together, birthing stars and clusters, just as our Sun was likely born. These nurseries recycle elements from past supernovae, seeding new stars and planets with the ingredients for life. Andromeda's tilted angle gives us a bird's-eye view of its spiral structure in star-forming regions. By studying these nurseries, we learn how galaxies renew themselves and how worlds like ours begin. Could there be life in Andromeda? With 1 trillion stars, the odds are good, but finding planets there is tough. Andromeda is too far for our usual planet-hunting methods. In 2021, astronomers used gravitational micro-lensing to spot a possible planet, Mega ML7b, in Andromeda. This technique relies on a rare alignment where a star's gravity magnifies the light of a background star and a planet causes a second spike. The candidate is likely a gas giant, but the event can't be repeated, so confirmation is tricky. Still, it's a breakthrough. We can find planets in other galaxies. As technology improves, we'll discover more extragalactic worlds. Each new planet tells us about the diversity of planetary systems across the universe. The search for life beyond the Milky Way has just begun. Galaxies are cosmic cannibals, and Andromeda is no exception. Its spiral beauty hides a brutal history of collisions and mergers. The galaxy's extended stellar halo is filled with stars from shredded dwarf galaxies, remnants of past meals. Hubble has mapped these tidal streams, revealing Andromeda's violent growth. M32, a compact elliptical galaxy, may be the core of a larger galaxy Andromeda devoured. Today, Andromeda is surrounded by at least 14 dwarf galaxies, all caught in its gravitational grip. Over time, these satellites will spiral inward and be absorbed. The process is ongoing. Andromeda is still growing, still feeding. Even its double nucleus may be a clue to this cannibalism. In the cosmic jungle, it's eat or be eaten. Andromeda's past is written in the stars it has claimed. Andromeda's story ends with us. The Milky Way is next on its menu. The two galaxies are on a collision course, set to merge in about 4.5 billion years. When they collide, stars will mostly pass by each other, but gravity will warp both galaxies, triggering bursts of star formation. The supermassive black holes at each center will eventually merge, creating a new, even larger black hole. The result: a single giant elliptical galaxy, nicknamed Milkomeda. Our solar system will survive, but its home address will change forever. If humanity endures, our descendants will witness the most spectacular light show in history. The night sky will be transformed, filled with the glow of billions of new stars. It's a humbling reminder, on a cosmic timescale, nothing is permanent. The universe is always changing, and we're part of its grand story.